Hi there. Today we're going to talk about square roots and perfect squares. So let's start by remembering two different numbers that can multiply together to give you 49. And when I say numbers, I mean integers. We're not talking about decimal values or fractions, just regular integers. So what number could you put into those blanks to create the product 49? Hopefully it's pretty easy for you to recognize that for at least one of them, we have 7 times 7. The second one might be a little bit tricky for you if you don't remember that integers include negative numbers. So we also could put negative 7 times negative 7 gives us 49. A negative times a negative is a positive. So we have 7 times 7 is 49, and negative 7 times negative 7 equals 49. When you have the same number multiplied by itself to give you a result, that answer, in this case 49, is called a perfect square. And the reason why they call it a perfect square is because if you go back to geometry and the area of a square, remember to find the area of a rectangle or a square is to multiply the two side lengths together. With a square, the side lengths happen to be the same size. And so what we have is 7 times 7, and the area of that square would end up being 49. Now, obviously, we can't talk about that with negative numbers because negative numbers do not represent distance, they represent direction, and we don't really use that when we're talking about shapes like squares and rectangles. So what we have is a perfect square, 49, because 7 times 7 gives us 49. So perfect squares are formed when you multiply a number by itself. So if we wanted to list some, we could say 7 squared is 49. And that's why the power of 2 is called a square, because 7 times 7 is 7 to the second power. It also represents that square that we just created. So we have 7 to the second power, or 7 squared is 49. We have 1 squared is 1, 2 squared, 4. 3 squared, remember it's not 6, it's 3 times 3, which is 9. 4 squared, 16, and so on. Now, some people like to memorize the squares. You can memorize as many as you'd like. It is encouraged that for 8th grade, you memorize up to 20 squared. And you might be surprised to realize that you have a lot of them memorized up to 12. And there's a few other in there that wouldn't be too bad. And hopefully you can recognize that 20 times 20 is going to give you 400 pretty easily. So really there aren't that many extra to memorize if you already know through 12. So what we have are perfect squares are formed when you multiply a number by itself. So 1 squared is 1. 1 is a perfect square. 2 squared is 4, making 4 a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. 16 is a perfect square, and you can continue on through all of the ones that maybe you have memorized. So those are all what we call perfect squares. So the title of this lesson is called Square Roots and Perfect Squares. So now you know what perfect squares are and what creates them. And don't forget that each of these can be created using negative numbers as well. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. Negative 3 times negative 3 is 9, and so on. So positive numbers can create perfect squares and negative numbers can create perfect squares. But all perfect squares are positive because a negative times a negative is going to give you a positive every time. All right, so let's talk about what a square root is. Okay, so remember, 49 is the perfect square. The square root of 49 is 7. It is the number that is used to multiply by itself to get our perfect square. So these side lengths in the square are called the square root. But you do need to recognize that we could also have a negative square root because a negative times a negative gives us a positive. So both 7 and -7 could be the square root of 49. How 49 is formed. All right, so there's a symbol on your calculator that you probably noticed before. It kind of looks like a division symbol. Looks like that. That is the square root symbol. And in this case, it is the positive square root. Some people call it a principal square root. You could also ask for a negative of the square root. So in this case, if you see this and there's no negative sign in front of it, if we wanted to find the square root of 49, it would look like that. And the answer to this would only be 7. They only want the positive or the principal square root. If they wanted the -7 as the result, then you would have to put the negative in front of the square root to say, well, what I want is the negative root. So in this case, we would see this and recognize that the negative is what they're asking for. So the answer is -7. So that would be the negative root. Every once in a while, you might be asked for both. If you are asked for both, you will see a positive and a negative sign in front. And that would mean that you would need to give both answers. So if we were looking for both answers for this one, you would be writing 7 and -7, or you could even write positive -7. Okay, so let's look at an example just to kind of compare two different problems. Looking at the not positive, but we're looking at the square root of 25 versus positive and negative square root of 25. So in this case, the answer to this, the square root of 25, is what number times itself gives us 25? Well, we know that we're going to fill in those blanks with the number 5. So the square root of 25 equals 5. And we only need to write positive 5. We don't need to write the negative because they asked for the principal root or the positive square root. They did not ask for the negative. If they wanted the negative, they would put the negative out front. If they want both answers, they will write this. So in this case, we would have both 5 times 5, giving us 25, and -5 times -5, giving us 25, which means we are going to write both answers, positive and -5. And you could write it like that to represent both numbers, or you could say 5 and -5. Both are acceptable. All right, so sometimes you might see something that doesn't look like it's a perfect square. Maybe something like this. The square root of 9/16. And what you want to remember is that even though this isn't an integer, it does have a nice square root because each part of that fraction is a perfect square. In our numerator, we have the perfect square 9, which is 3 times 3. In our denominator, we have the perfect square 16, which is 4 times 4. So if we were to take 3/4 times 3/4, we would get 9/16. This times this, same number being multiplied together to get us this, tells us that the square root of 9/16 is 3/4. So don't let the fractions scare you. Don't look like it as a tricky problem. You just break it into pieces. The numerator is 3 squared. The denominator is 4 squared. So the square root of 9/16 is equal to 3/4. Okay, let's call that part A. Let's add another part to it. Now we're going to find both the positive and the negative square root of a decimal. Again, doesn't look like it's going to be easy. There's a decimal. It's not an integer. But if you ignore the decimal for a moment and recognize that 81 is 9 times 9, you can find the square root of 0.81. You're thinking of a number that when you multiply it together, you get 0.81. Notice we have 2 digits after the decimal here, which means that we're going to need 1 digit after the decimal in each of these, and that digit is a 9. 9 times 9 is 81, so 0.9 times 0.9. 9 times 9 is 81. 0.9 gives us 2 digits after the decimal in our original question, which means we move the decimal 2 places to the left to give us 0.81. Now remember, it did ask for both positive and negative. So you could say plus or minus 0.9 if you'd like, or you could say 0.9 and negative 0.9. So square roots are the number that is being multiplied by itself to give you the answer that's under the radical. This symbol is called a radical or a square root symbol. Perfect squares are formed when you multiply a number times itself. So 9/16 technically is a perfect square because 3/4 times 3/4 is 9/16. We could even draw that square. This side length would be 3/4. This side length would be 3/4. Maybe we're talking about 3/4 of an inch. Maybe we're talking about 3/4 of a mile. It doesn't matter. It's still a square. And so that perfect square created here would be 9/16. 3 times 3 gives us the 9. 4 times 4 gives us the 16. So perfect squares are formed when two numbers multiplied together that are the same give you a result that is a perfect square, and the square root is the number that has been multiplied by itself.